Okay, we've got a function where we're starting with an f of an x and we want to find f inverse of x. And there's some other stuff as well around domains and sketch graphs and so on. But the first bit, the algebraic part, is just a template, by which I mean you can just learn a standard procedure. And indeed you must learn a standard procedure, because if you do that, it's self-working, and if you don't, then you'll get it wrong. So in order to get started on this, we're going to start with the function written in terms of y and x. So we've got f of x here, okay, but I'm going to change that into a y. So I'm going to say that y equals x squared plus 5. And that is true for f of x. So I'm just going to make a note that that was for f of x. But I'm going to go immediately to look at for f inverse of x. Now some people like to do this step at the very end. I like to get it out of the way at the beginning. Okay, so what's the difference between f and f inverse? Well, the point about an inverse function is it takes me back from the original output to what was originally the input. Okay, it interchanges the input and the output of the function. So that means it interchanges x and y. So I'm going to do that. I'm going to say that x equals y squared plus 5. And I could even stop and say that there's your inverse function, but it's not written in the normal way. We would expect, okay, this x, okay, the input of the function, to be inside the formula, and would expect the output y to be the subject. Okay, so the rest of the process is just to make y the subject of the formula. So I'm going to do that with ordinary algebra. So I'm going to do x minus 5, okay, equals y squared, and then I'm going to get y. Okay, how do I get y? Well, I've got to undo the squaring. Okay, so, all right, this is where it begins to get interesting. Y equals the square root of x minus 5. Okay, well, when you do that, you should be thinking very clearly, do I need a plus or minus in front? And normally you do. Okay, all right, but I'm just going to stop there and say, that's the template. Okay, you take your original f of x, you write it out using a y instead of the f of x. You say that that's for the original function. Then you say for the inverse function, x and y change places. Then you make y the subject of the formula. Okay, and quite a lot of the time you're done. All right. Now the question we had is, should we leave this plus or minus in front? Well, you know what? I'm going to put the plus or minus in. I'm going to say that you should never just ignore the plus or minus and hope for the best. We actually need to make sense of this. So do I need both? Or do I just need one of them? Well, at this point, I'm going to look at this thing in the brackets. It says, I may wish to sketch the graph of f of x to help me think about the range of this example. Okay, it's not just ranges I need to think about, it's the domain. So y equals the original function, y equals x squared plus 5. Well, that's a parabola. It's one of these. It's got plus number of x squareds. So it's a parabola this way up. And in fact, the plus 5 just shifts it up by 5 units. So this is the original graph, except it isn't, because the domain of the original graph, so the x values that I'm allowed to put in, the domain of the original function, okay, was x is greater than 0. And 0 is here on the x-axis, and here are the ones that are greater than 0. So in fact, it's only this part of the graph I want. Okay, so this part of the graph doesn't exist. Okay, so that means that when I go from a function to its inverse, and x and y change places, remember that's reflection in the line y equals x. We saw that in another example. So this bit of the graph that I do want, okay, all the x's and y's on this are going to change places. So in particular, this point at 0, 5 is going to map onto the point 5, 0. Okay, so the point 5, 0 goes down here, this point will go here, this point will go here. So I'm going to get my half parabola, because remember this is only half a parabola, this bit over here I just don't want. Okay, so my half parabola here is going to reflect onto this half parabola here. I haven't drawn it very well, but that value there is 5. So the equation of this graph should be this, and now I can answer my own question. Do I want plus or minus? Well, if I included the negative answers, then for every time I got a positive answer to the square root, I'd get another answer down here, it's negative, and I'd get these answers down here. But that would be the reflection of this half of the parabola that I didn't want. So in this particular case, okay, because of our graph, we can see that we need f inverse x is just the positive square root of x minus 5. And the other thing we've got to do and drag into this is the idea of range and domain. So I've already got the domain of the original function. Okay, if I think about the range of the original function, okay, so the range, remember from earlier in in the work we've been doing recently. The range is the possible y's I can get. So all of these points on the original graph will give me these y coordinates on the y-axis, with the bottom y coordinate, the lowest one I can get, being this 5. So the range is just the values of y, or f of x I should say, are greater than or equal to 5. Okay, so I've got the x's that I'm allowed on the original graph are all values greater than 0, and the ranges on the original graph are all values greater than or equal to 5. Oh, sorry, this is strictly greater than 0, so I don't want greater than or equal to 5. I'm not allowed to actually be at that point there, because that would require x to be 0, which I'm not allowed. So I've got my original domain, which refers to x, and my original range, which refers to y. Now, okay, what's that got to do with the inverse function? Well, remember, for the inverse function, we're reflecting in y equals x. X and y are swapping places. The point 0,5 goes to the point 5, 0. So that means that domain and range change places. So for my inverse function, okay, my domain and my range are going to be exactly what the range and domain were for my original function, except the other way around. So the domain is going to be what the range was originally, which is greater than 5. Okay, except I don't say f of x is greater than 5, because now I'm looking at this graph. Okay, the domain of this graph is the x values that I can put in, all of these x values. Okay, not including 5, this point is not included, but 5, any value bigger than 5 works as an x. So domains always refer to x. So it's this same set of values, but described using an x. Okay, and the range of this, okay, well, the range of the inverse function, okay, what y values can I get here? Well, it's everything. This point is not included, so I can't get 0, but I can get all of these values above 0. So the range is going to be all values greater than 0. Okay, now I could use y, but I shouldn't really. I should talk about the function of x, but it's not f of x I'm looking at. This is the graph of y equals f inverse of x, not f of x. So the range is described as f inverse of x is greater than 0. And comparing with the original domain, I can see it's the same set of values as the original domain. But because it's a range, I have to describe it using f inverse of x greater than 0, not saying x is greater than 0. So have I answered the question? I found f of x, so that's f inverse of x, so that's good. And I found the domain of this inverse, and for good measure, I've said what the range of the inverse in as well is as well. So I am done. Okay, but this missing off this plus or minus is important, and you can see actually, just to round it all off, because the graph tells me the range of the f inverse is all values greater than 0, then that tells me that the negative answers minus the square root of x minus 5 are the ones I don't want, so that's why that's ruled out. Okay. Oh, before I go, one more thing. Why have they bothered to restrict the domain? Is it just to be awkward? No, it's not, because if they'd left the original graph in its entirety, if I'd tried to use a domain of all real values of x, positive and negative, then I would indeed have reflected this entire parabola. Okay, so please don't transfer the remaining bit into your notes, because I'm now mucking up this graph. This graph should not be the whole parabola, okay? Because if it was, then I'd get this whole parabola when I go to the inverse. And why is that not allowed? Well, because this is not a function, okay? This now is trying to, for each individual x value, like that one there, okay, there'd be a y value up there, but it'd also be another answer down here. And functions aren't allowed to do that. Functions are not allowed to have two different answers. So I can't have both halves of this parabola. I could have chosen the other half, but I didn't. I chose to have this half of the original parabola, so I've got to have this half of this one, and now the inverse is a function. Okay, so that's something else that's come up in your notes. Okay, for an inverse function, okay, so for an inverse to exist, all right, f of x must be 1 to 1. Okay, but this original graph, if I'd had the entire parabola, that wouldn't have been 1 to 1, it would have been many to 1, because there are two different ways of getting to this point on the y-axis. That makes it many to 1. I'm not allowed to have many to 1, I've got to make it 1 to 1. And by destroying this half of the graph, what's left here does just have one x value leading to each possible y value. So destroying half of the graph is necessary to make the function 1 to 1, which is what we need for it to have an inverse in the first place. So Quite a lot going on in this example. The easy bit was getting the algebra, but don't forget this template. That's important. Okay. And the other key point is that, well, two key points. When you go from a function to its inverse, range and domain change places. So it was easy to write these two down if I knew the original domain and range. And third point is that for an inverse function, we need the original function to be 1 to 1.